Hello guys, I came up with a new concept that is Karatsuba algorithm for fast multiplication. As you all know, I am Chetana studying in Sri Venkateshwara College of Engineering pursuing Computer Science and Artificial Intelligence Engineering. So this algorithm comes under data structures. This approach comes under divide and conquer strategy. So let us see. It was developed by Anatoly Alexeyevich Karatsuba in 1960 when he was only 23 years old. The algorithm reduces the number of multiplication operations required for multiplying two numbers. So what is the basic idea? The basic idea is to divide the problem into sub-problems that is smaller, and then applying the recursive technique so that we'll get many solution, and then by integrating that solution we'll get the final solution. And the context of Karatsuba algorithm, the number of multiplied parts are split into smaller parts. By recursively applying the algorithm to the parts, the final result can be obtained efficiently. Recursive multiplication process. When multiplying two n-digit numbers using Karatsuba algorithm, the numbers are split into two halves, each with n by 2 digits. As you can take like a 4-digit number, the 4-digit number can be divided by 2, so you can multiply two numbers so that you will get the optimal answer. The algorithm computes 3 multiplication of smaller numbers instead of usual 4 in traditional multiplication. These multiplications are combined in specific way to obtain the final result. Let us see the example. So this is the example for uh, 4-digit, and there is also a combination of 4-digit and 3-digit number. You may get the question that how is it possible if both number the digits vary. So here we can take the example of 4 digits and 3 digits. In 3 digit, we'll replace one more digit by adding 0 before the number, so that we'll get equal parts, and we are finally multiplying, and we are doing the operations, and I'll give the formula in the next slide. So this is the steps we are going to make. Step 1, in this algorithm we assume that n is a power of 2. Step 2, if n equals 1, then we use multiplication tables to find p equals xy. Step 3, if n is greater than 1, the input digits numbers are split into off and represent the number using the formula x equals 10n by 2x1 plus x2. So this is the formula for solving the parts of the problem instance. And step 4, take a variable z equals w minus u plus v, where u equals x1 y1, v equals x2 y2. Here x1 is the first two digits of the 4-digit number, and y1 is the last two second numbers first two digit, and v equals x2 and y2, where the last part of first digit number and last part of second digit number. So this constitutes u and v. Then we are applying the formula for w, and we will get finally the z. Let's move on to the step 5. we are finding the product using step 5 using this formula as I said before in the step 3, and in the step 6 we are recursively again applying this formula and passing the subproblems x1, y1, x2 and y2 which we are divided in the initial part, and finally combining it separately and then returning their values. So this is all about the formula and finding the solution. Let's see about the time complexity. Karatsuba algorithm has a time complexity of O of n power log 2 of 3, that is approximately equal to O of n power 1.585, which is more efficient than the traditional O of n power 2 multiplication algorithm. So here we can see in traditional way we are getting answer in n power 2, whereas using Karatsuba algorithm we are getting answer in 1.585, that is 1.6 something. So yeah, it is possible, and if it is possible we can use it, and it is also efficient way. It mainly saves the time. The reduction in the number of multiplication operation results in faster multiplication for large numbers. So this is the one main advantage. The algorithm is particularly beneficial for multiplying very large numbers efficiently. Let us see the advantages of Karatsuba algorithm. Efficiently multiplies large numbers with fewer multiplication operations, reduces the overall time complexity for multiplication tasks widely used in cryptography, signal processing and other communicational fields for fast multiplication. Then if there is advantage, there should be a disadvantage. Let's see the disadvantage or limitation of Karatsuba algorithm. Karatsuba algorithm is not always the most efficient for small numbers due to the overhead of recursive calls. The algorithm requires additional memory for storing the intermediate results during the recursive computation. Then implementing the algorithm efficiently for hardware multiplication can be challenging. So these are the advantages and limitations of Karatsuba algorithm. Let us see the applications. It is, as I said earlier, it is used in cryptographic algorithms like RSA and elliptic curve cryptography for fast modular multiplication, applied in signal processing for efficient convolution and Fourier transforms, utilized in computer algebra systems and libraries for high performance arithmetic operations. So these are all the applications of Karatsuba algorithm. In conclusion, Karatsuba algorithm is a powerful technique for fast multiplication based on divide and conquer. It offers significant advantages in multiplying large numbers efficiently. Understanding and implementing the algorithm can lead to improved computational performance in various applications. So this is all about Karatsuba algorithm. Let's meet in the next video with a new concept. Thank you for watching, guys.